We can solve this system by either using the substitution method or the addition method. Since in the first equation x is already by itself, I'll go ahead and use the substitution method. I'll take that 4y minus 8 and substitute that in for the x in equation 2. Because x is the same as or equal to 4y minus 8. So where we see that x, we can replace it with 4y minus 8. That gives us an equation that only involves a variable y. Go ahead and distribute the 5. And if we combine like terms over there on the left, 20y minus 20y is 0. So all I'm left with on the left-hand side is negative 40. On the right side, I also have negative 40. There's no more variable in this equation, so there's nothing remaining for me to solve. If you wanted to take another step, you could. You can add 40 to both sides. That gives you 0 equals 0. And no matter which step I stop at here, either the negative 40 equals negative 40 or 0 equals 0, it tells me the same information. There's no variable left, so there's nothing for me to solve. But this is a true statement. Negative 40 is equal to negative 40. 0 is equal to 0. That's indicating to me basically that no matter what I plug in for y, this statement here will always be true. So I can plug in any number for y and get a true statement there. Once I pick something for y, the corresponding x value is 4y minus 8. So I could figure out the x-coordinate that goes with it. But since y could be anything, there are infinitely many solutions. And now even though there are infinitely many solutions, they still have to be in a certain form, as I briefly mentioned a minute ago, where once I pick a certain number for y, there's only one specific value of x that goes with it, found by evaluating x equals 4y minus 8. So, although there are infinitely many, they all still share a form. It's not that I can randomly choose an x value and a y value. I can't do that and get it to be a solution of the system. I can randomly choose a y value, but once I do that, then the x has to be a certain value in order for it to work. So I'm going to indicate that by saying the solutions are the set of all ordered pairs xy such that, is how we read that bar, and then I just need to pick one of those equations. Essentially what we've just figured out is that these two equations are equivalent. They generate the same line if I were to graph them. So just pick one. I could say x equals 4y minus 8. Or I can give my solution as the set of all xy such that 5x minus 20y equals negative 40. So either one of those options paired with the conclusion that there's infinitely many solutions would be sufficient